Hey everybody, welcome to another con support video. This one's on one-step equations with negative numbers, adding and subtracting. So it's pretty straightforward. I'm going to go over the basics of solving an equation and hopefully it gets you guys comfortable. All right? So first things first, the main rule for any equation is whatever you do to one side, make sure you do it to the other. So your goal when solving an equation is to get the variable by itself. And you want to make sure that when you find the value of that variable, you check it by plugging it back in and seeing if you get a true statement. So let me show you kind of an example of what this would look like. So number one says negative 0.2, and you're setting that equal to s plus negative 0.8. And your goal is to get this s by itself. We call this isolating the variable. So you want to get this s all by itself. So you want to get rid of this plus negative 0.8, right? Well, how do I get rid of this negative? I have to add the opposite of the negative to get rid of the negative, to cancel it out. Well, what's the opposite of negative 0.8? Positive 0.8. So if you were to add a positive 0.8, you always work down one step at a time when you're doing your algebraic solutions. So you would add a positive 1.8 or 0.8 to both sides. Whatever you do to one side of the equation, you have to do to the other side. So over here, you're going to add a positive 0.8. Okay, so whatever you do to one side, you do to the other. You can think of it like an imaginary line that goes down the middle there. Let me do it like a pink line. Here you go. See? It's like a little equals line there, right? And whatever you do to one side, you got to do to the other to maintain the balance. It's got to stay balanced, okay? So we want to get that s by itself. The nice thing is that when you have a negative 0.8 and you're adding a positive 0.8, these two become what we call a zero pair. So I'm just going to take that and circle it to show that it's a zero pair. In other words, they cancel each other out to zero. So this all goes away to nothing. And then over here on the left-hand side, you have the result. Now, what is negative 0.2 plus positive 0.8? Who's going to win? Positive by how much? 0.8 take away 0.2, which is 0.6. So the ultimate value here is 0.6 on the positive side, and that should be equal to the value of s. All right? Now, I think that's right. I just got to check it. You always want to check your answers when you're doing any algebra. So here you check it by going, what is the value of s? 0.6. Let's plug that back into the original and see if we get a true statement. In other words, is it true that negative 0.2 is equal to 0.6 plus negative 0.8? And in this case, you can see that there is a battle, tug of war. Who's going to win the negative by how much? 0.2. So yeah, this is going to be a true statement. Whenever you do any algebraic solution, you want to check to see if your variable solution works, which means you're going to plug it back into its original location in the original equation and see if you get a true statement. And as you can see in green, it does give you a true statement when you check it. So I feel very happy about that check. Okay? All right, now that we got that one done, let's do the next one. So I'm just going to kind of set that up here. You know, we can probably use that same equation line. So I'm just going to, I guess I could, yeah, let's leave it. Let's leave it. Let's do it like that. Okay, cool. So once we do that, I'm going to kind of erase this. We don't need it. Okay, let's do the next one. This is going to be a value of 0.6, so 0.6. There we go. Next one. This is 17 equals negative 14 plus k. So here we've got 17 is equal to negative 14, and you're going to add k to that. You want to get the k by itself. We call that isolating the variable. So you're trying to get that k all by its lonesome. Well, what's happening to that k is negative 14, right? You're taking away 14, you're adding a negative 14. So you got to get rid of that plus a negative 14. So how would you cancel out 14 negatives? You got to add 14 positives, right? If you were to add positive 14 to both sides of this equation, all right, you're going to maintain the balance because you did it to both sides. And negative 14 plus 14 is going to be a big old zero pair, right? That's going to go away to nothing. So then you're isolating the variable because now we know that the value on the right-hand side of our equation is just going to be k. And on the left-hand side, you just got 14 plus 17, which is going to be 11, carry the 1, so that's going to be 31, right? So that's 31. So what's the answer? 31. How do we check to make sure that it is the correct answer? Well, we take this value of the variable and we replace the variable with that. So we go, all right, let's plug it back into the original and see if we get a true statement. So let's do a little check for it. So in other words, is it true that 17 is equal to negative 14 plus 31? Well, that'll be a battle between 31 and 14. Who's going to win the positive 31? By how much? And then it's going to be 17, right? Because 31 take away 14 is 17. So it does work. Makes sense. And there's your check. So the answer here should be that k is equal to positive 31. Okay, let's do the next one. The next one says, number 3 here. All right, this one says negative 11 is equal to p minus 9, okay? Your goal is to get the p by itself, so you're going to try to isolate that p. So you got to get rid of the thing that's happening to it. Well, what's happening to it is the subtracting 9 or adding a negative 9. How do you get rid of taking away 9? Well, you'd add 9 to both sides. If you added a positive 9 to both sides, that would cancel out that negative 9, right? So add 9 to not one side, but to both sides, and then see what you get. The negative 9 or take away 9 and the plus 9 is going to be worth 0 because negative 9 plus 9 is nothing. And then you're left with, on the right-hand side, just p. And the left-hand side, the answer. What is p worth? Well, negative 11 plus 9, who's going to win? Negative by how much? 2. So the correct answer here would be that the answer is negative 2 is equal to p. Now you've got to check this out and see if it works by replacing p in the original equation with negative 2 and seeing if you get a true statement. So let's do a little check. Is it true that negative 11 is equal to negative 2 minus 9? Well, negative 2 minus 9 is exactly the same as negative 2 plus the opposite of 9, which is what? Negative 9. So that's the same as negative 2 plus negative 9, which is negative 11. So is negative 11 equal to negative 11? Yes. We just did our check. Good job. For every algebraic solution, you always want to plug it back in and see if you get a true statement with the value that you think works. Let's do the next problem. So this one's going to be negative 2. Negative 2. Boom. Done. Next one. Okay. Oh, we got some fractions here. They're making it fun for us. Some variety. So we're going to do number 4 here. This is 17/20ths. And you are setting that equal to the value of t plus the value of negative 13/20ths. Okay. Well, you want to, once again, isolate the variable. So you want to get this t all by itself. So you got to get rid of this plus negative 13/20ths, right? Well, what's going to cancel out negative 13/20ths? It's adding a positive 13/20ths, right? So we're going to go over here. We're going to add a positive 13/20ths, not to one side, but to both sides of our equation. Whatever you do one side, you always have to do the other side. And you're going to notice that negative 13/20ths and positive 13/20ths cancel each other out to become 0. So they go away to nothing. And then you have the answer, which is 17/20ths plus positive 13/20ths, which is going to be 30/20ths. And 30/20ths is going to be the value of t. Now that can be simplified, of course, to 3/2, or to 1.5, or to 1.5. Lots of ways to write that. I'm just going to put it as 1.5. And that's it. So you can put it any way you want. When you want to check this value, I think the easiest way to check it is probably to write it out of 20ths, right? So that'd be 30/20ths. So if you were to check it, I would go back up here and I would just plug it in and do my little check for it. So here's my little check just to prove that it works. We already know it does. It would be 17/20ths is equal to the 30/20ths and then plus the negative 13/20ths. And as you guys know, 30/20ths take away 13/20ths would be 17/20ths, so it works perfectly. We got that right. All right, let's do the next one. All right, this one's got some decimals. Ooh, they're mixing it up. We got some decimals to work with. Yeah, it's fine. It's the same stuff, right? So we're going to do the exact same thing we did before. We're going to isolate the variable by undoing addition or subtraction, right? So here we have a take away negative 3.75. And that's set equal to 6.11, okay? Now, we want to isolate that variable a once again. So we got to get rid of this take away a negative 3.75. Well, this is a little tricky if you're not thinking carefully, so let me slow it down for you. Taking away a negative, as you guys know, is the same as adding the opposite of a negative, or adding a positive. So we could rewrite this as plus, let me try that again. I'll write that in pink here. Good. This is the same as plus 3.75, right? And now I think it makes a lot more sense in how we can kind of go from there to get the correct answer. So we want to get rid of this plus 3.75. So what are we going to do? We're going to subtract 3.75, not from one side of the equation, but from both sides of the equation. And so this on the left-hand side becomes a 0 because what is 3.75 minus 3.75? Nothing. And we get a is now equal to whatever this result is. So you can do this anywhere you want. I'm going to do it over here. A little more room to work. So I'm going to do 3.75 off to the side, subtracted from 6.11. And when we do that, I'm going to get borrow from the 6, make it a 5. This becomes 11. When borrow from it makes it 10. And this becomes 11. Okay? So we got 11 take away 5 is 6, and 10 take away 7 is 3. Bring your decimal down, and 5 take away 3 is 2. So what I get there is 2.36. Okay? So the final answer is going to be that positive wins by 2.36, or that A is worth positive 2.36. And then you want to check your work, right? So let's do a little check for this, make sure we got it correct. So we say, all right, let's test it. Is 2.36 take away negative 3.75 in fact equal to positive 6.11? Well, taking away a negative is the same as adding a positive. So really what we're asking here is 2.36 plus 3.75 equal to 6.11? And that you can check out over here. We'll do it. We'll just do 2.36 and 3.75. We're going to add them together. And then 6 plus 5 is 11. 1 plus 3 is 4 plus 7 is 11. And then 1 plus 2 plus 3 is 6. So does it work? Yeah, it works great. So we're done. All right, so the answer here should be, after all that, 2.36. And now we can go to the next problem. So this is number 6. I'm going to add a new page here because I'm running out of space. I'm probably going to upload this for you guys so that you have examples of how to solve equations. So let's do this one, number 6. Okay, so here's number 6. And it says b minus 7/4 should be equal to negative 2/3. Okay, fair enough. So we were going to want to isolate the variable, which is b, which means we want to get rid of this take away 7/4. Well, how can you get rid of take away 7/4? You should be thinking I'm going to add 7/4, right? Because I want to just cancel that out. If I add 7/4 to the left, I better add 7/4 to the right. But here's the thing, thirds and fourths can't easily combine, so I'll probably need a common denominator. This becomes 0. This is a big old 0 pair. The b is the value that we have on the left. On the right-hand side, we got to figure what this is worth. Now, this is the same as common denominator of 12. So this would be times top and bottom by 4 on this one. So negative 8/12, and then plus how many 12ths? Well, times top and bottom by 3. So plus 21/12. Who's going to win this battle? The positive by how much? So we're going to get a positive answer here. And then what's it going to be positive? What value would it be? Oh, 21 take away 8, right? So 21 take away 8, take away 1, you get to 20, and then you got to take away 7 more. So it looks to me like it's going to be 13. So it's going to be 13/12 as your answer for B. And then you got to just check it, see if it works. So we're going to do a little check and see if we get the right answer. So this would be 13/12, take away 7/4, should say 7/4 should be equal to negative 2/3. Let's see if it is. Common denominator would be 12. So this is 13/12. Take away times top and bottom by 3, 21/12. Times top and bottom by 4 is equal to negative 8/12. Okay. So let's see if that's a true statement. Is 13/12 take away 21/12 equal to negative 8/12? Yeah, the negative is going to win by 8, so that works. And so we got that one right. So the answer here should be positive 13/12 for B. And there's your answer. And last but not least, we've got a little decimal problem here. So what we're going to do is we're going to do number 7 here very nicely. And it's going to be D plus the value of negative 5.004 is equal to 2.826. All right, fair enough. You want to get the D all by itself. We call this isolating the variable. So we got to get rid of this plus negative 5.004. Now, plus negative is the same as taking away a positive. So it's the same as take away 5.004, right? So if you want to cancel that out, you got to add a positive 5.004. So we're going to do that. We're going to add a positive 5.004 to both sides. So you're going to add positive 5.004 on the left, and you better add positive 5.004 on the right as well. Okay? When you do that, you're going to get a zero pair here because they are canceling each other out like they're supposed to. And then you get the value d on the left is equal to the sum of these two. Now, both those are positives, easy to add them together. So 6 plus 4 is 10, so it's a 0, carry the 1. And then 1 plus 2 is 3, 8 plus 0 is 8, and 2 plus 5 is 7. So it looks like it's going to be positive 7.830, or 7.83. And then you can check it, of course, to see if you got the answer correct. So you can just go, is it true that 7.830, if you will, is combined with negative 5.004, and you end up with 2.826. Well, let's just test this out and see if it works. So this is pretty straightforward. It's just going to be 7.830. You're going to be subtracting 5.004 from that. Let's see what happens. So when we do that, you're going to borrow. This becomes a 2. This becomes a 10. 10 take away 4 is 6. 2 take away 0 is 2. 8 take away 0 is 8. And then 7 take away 5 is 2. So these are the same. It matches. We're good to go. The answer must be then 7.83. You don't need the 0. And that's how you do it. Hopefully that helped you guys.